density. It's as Raina said, it's mass divided by volume. So mass is how much space something takes up. It does have to do with weight, but it's not just weight. It has to do with the space something is taking up in relation to its weight. When we talk about the space something takes up, that brings us to volume. So that's when you take that mass divided by volume. So we're going to explore how density of a material can change, like how dense something is, and what can cause those changes. So by the end of this lesson, I hope that you will be able to demonstrate an understanding of density and how density of a material is determined. Apply scientific vocabulary to explain how changing the amount of a material can affect its density. And complete a Frey model for key vocabulary words. So we're going to go through a process. It says it's going to take about 45 minutes. I might skip a few slides to keep us within 45 minutes. But again, these are also posted as a student-paced lesson where you can go back and look. So we're going to get started. So I just kind of asked this question, but what do you already know about density and how the density of a material is determined? When we talk about density, think about how dense something is. If someone said that's very dense, what would they mean by that? You can type in your responses and hit post. I like the responses I'm seeing. Mass over volume. Um, Density is how tightly packed together something is. That is a great way to describe density. How tightly packed something is. Density is the compactness of a substance. You can find the density of an object by dividing mass by volume. So I know we've been talking about states of matter and our solids, liquids, and gases, and we've been talking about how the atoms move and how much they're spaced out or not. So in knowing that, think about which state of matter is the most dense and which is the least dense. And you can type that answer if you would like. You can put another post right here in the chat, or or in the Nearpod. So, which of our solid, liquid, or gas, which is the most dense? Which is the least dense? Think about the movement of the atoms. Jemiah? Yes, solid is the most dense because remember, all those atoms are really tightly packed together. And gas is the least dense because all of those atoms are spread out and they're kind of bouncing off the walls and bouncing off each other. All right, good job, y'all. All right, so we're going to take a quick poll. The density of a sample material is dependent on the amount of the material present. So that sentence means the density of a sample of material. So we're thinking about a substance. So how dense it is, how compact, is dependent on the amount, like how much material is present. Is that true or false? And this is kind of a tricky question. And it is why we're doing it as a poll. So I'm looking, I still have some people that haven't answered yet in our, poll. But when we're talking about a material, we're not talking about how compact the material is. We're just talking about the amount of the material. So does the density change? So like if I have 1 cup of water and then I have 1 gallon of water, does the density change from the cup to the gallon? Both of them are water. Both of them are the same substance, the same material. Does that density change based on how much water I have? Think about that for a minute. And then I'm going to answer it. So if I had a cup of water and a gallon of water sitting next to each other, if I was to take the density, that's the mass over the volume, would the density change? So this is, Leah, do you want to answer us? Yes, please. This is why this is tricky. It's actually false. So the density of a sample material, or for instance, the density of water, if we're talking about water, but it can be any material, does not change no matter how much I have. So that the density of a glass of water, just like 1 cup of water, is the same density as a gallon of water. So I want you to think about, let's think of another material. So if we talk about a shirt. So I am an adult, so my shirts are larger than my daughter's shirts. So if I order a shirt, and I order us the exact same shirt, our shirts, even though hers is smaller, it has less material, her shirt and my shirt are going to be the same density. It is the same material. It is made up of the same thing, so it has the same density. Just because I needed more material to make my shirt than my daughter needed doesn't change the density. So the density does not change based on the amount of the material. It's a tricky question because you almost think like when there's more of it, it's going to get more compact, but it's not. If the material itself is always going to have the same density. Raina, you have a question or you want to comment? Yes, but the mass is not necessarily going to change. And so we're going to talk about that a little bit more about mass versus weight. So we're going to do a virtual kind of exploration of a balloon festival. So if you are in our Nearpod, you can actually use your mouse and kind of click and move around. If you click the enter VR, that's like if you had VR goggles. Um, and if you don't, it's going to look kind of strange. So unless you happen to be on a cell phone with VR goggles, I would stick to the regular setup. So as you're exploring, I want us to look at, the hot air balloons, and I want you to think about, how hot air balloons work. You may know and you may not, and we're going to talk about it a little bit. I kind of give you a little bit to explore. Click around. You see a pack of chips. Give us about 30 more seconds before I start talking. So, with a hot air balloon, this ties right into our atoms and our states of matter. So, the inside of a hot air balloon is filled with gas. And those gas particles, you know, are all around. But in order for it to fill up the balloon, is we need to increase the pressure or increase the movement of those atoms. How can we increase the movement of atoms? What do we need to add? Mia? Yes, exactly, Mia. So in a hot air balloon, they're adding, you said that fire, they're adding thermal energy or heat. They're adding thermal energy or heat. When we add heat to gas or any substance, the particles, those atoms, start to speed up. So if they were kind of moving at a medium pace, because if they're a gas, they're moving pretty quickly no matter what. But when we add thermal energy, we add that heat, they start to speed up much faster, and they start to crash into each other and crash into their container. In this case, the balloon. So as they crash into it, this is what causes it to expand or spread out. And this is why a hot air balloon can rise, because the gas and the air inside, we're actually changing the density. Now, when I say that, it's because we're changing with heat, we're changing how fast those atoms are moving, and that actually changes the density. Yes, Leo? Yes, exactly. Because that fire is adding thermal energy, and that energy is giving energy to the atoms. It transfers to those atoms, so they're speeding up. Yes, excellent. So, when we heat the air, the inside has been heated and it rises because of the change of the density. So, the hot and the cold air particles, so the inside of the balloon becomes less dense. So, hot is less dense, cold is more dense. If you think about when you're cold, I want you to think about you kind of maybe like want to curl up with a blanket and kind of settle down, and you're kind of more still. So cold, I want you to think of it's moving slower, but it's also heavier. So when you think about how heavy something is, think about how dense it is. Something that's really heavy, like a bowling ball, is very, very dense. It's very heavy. So when things are cold, they slow down because they get heavier, or they get denser, is the correct way to say it. So their density increases, so they sink down. So they get more dense, they get heavier, so they will get, they'll drop. When we add heat, the density actually decreases. We get lighter, so we rise. And I know when you've learned about fire safety and you've learned about smoke rises because smoke is less dense than the air, so it will rise up. When you think about like birthday balloons, you can get the balloons that you blow up yourself, and they don't float, right? They'll kind of sit around on the floor. They're fun to like toss around and hit to each other. And then you can also get helium balloons. Well, helium is less dense than oxygen and the air that we are, around and we breathe, because helium, with it being less dense, it's going to rise up just like these hot air balloons. So heat will make it less dense. So we're going to watch a short video about density. Kind of pay attention to the vocabulary. I'm going to disconnect my headset really quick so that you all can hear it. Give it a second to load.
Welcome to All Today.
So, if you are in the Nearpod, if you would switch over to Teams to watch our video really quick. So just switch back over here to Teams so that you can see our video. Leah, did you have a question?
It says that the video is paused on this device when when it's showing the video on the Nearpod.
Yeah, I paused it on my device. So if you will switch over to our team meeting so that I can play the sound and everyone can hear it and see it, and we're not all playing sound at a different time.
Okay.
So you're not going to hit play on your screen. You're going to come over and look at my screen.
Excuse me?
Okay.
Yes, Leah?
I did this already, but I want to do it again.
Okay. That's fine if you did it already. All right, so I'm going to hit play.
Hello there, Jacob, and welcome to Are You Dense? I'm Michael, and I'll be asking you some true or false questions. The grand prize is a summer internship at NASA. First question, true or false? Density is dependent on the amount of material present.
True. Because if an object were bigger and heavier, it'd have to be more dense.
Are you dense? That's a misconception. Density does not change with an object's size. If the material's makeup is consistent throughout, then the size will not affect its density. And when you say something is heavier, you're actually describing the object's weight, not its density. Density is how much mass the stuff is packed in a volume, and it's measured by mass per unit volume.
Wow, that's a lot.
Yeah, I know it's a lot to take in if you're dense. But an object's density also affects whether the object can sink or float in water. Let me give you an example. Say if you have a slice of bread and a loaf of bread. Both float, even though the loaf of bread is obviously bigger. This is because the loaf and the slice of bread are made up of the same thing, so they have the same density.
So I get the idea of them floating, and they both float because the amount of wheat in the bread, compared to the size, it stays the same. So the density of an object doesn't change with the mass of the object, but rather by the mass compared to the object's volume.
Exactly. But sorry, just missed out on an internship at NASA. How do you feel?
I feel like I believed the Earth was round. It's so crazy.
You're saying the Earth is flat?
Yeah, why wouldn't it be?
I'm done with this guy. The Earth is round. These flat earthers make me crazy.
I know that was a little bit laggy. Alright, you can switch back over to your Nearpod and answer our poll here, which is the density of a sample's material is dependent on the amount of material present. Same poll as before. So, is the density of a material dependent on the amount of material? Think about that bread floating. Does the amount of bread, a slice of bread or a loaf of bread, does that change the density? The density of a sample material is dependent on the amount of material. Is that true or is that false? I see a lot of correct answers going up. You guys are doing good. I still have some of you have not answered yet. But the 44% that have answered, your answer of false is correct. Again, the density of a sample material, so let's change the sample material to bread. The density of bread, or the density of a loaf of bread, is dependent on the amount of bread present. No, it doesn't matter if it's a slice of bread or a loaf of bread. So this is false. The density will always be the same. And yes, while there's more of it, and you think about, okay, well then that increases its mass. Yes, it does increase its mass, but that's why you're dividing it by the volume. When you divide it by the volume, remember volume is the amount of space something is taking up. So when you divide the mass or the weight that an object is, yes, it increases with material, but then you're dividing it by volume. So you end up getting that same unit of density. All right. So we talked about what is density. We talked a little bit about, well, we're going to talk about what you learned from watching that video. How does density of material change as the amount of material changes, or does it change? And then we're going to learn and talk about the law of conservation of matter and how we find the density of a substance. So, with our states of matter, on the next slide, we're going to use an interactive simulation. Let me look at the time. All right, I think we're okay still. When we talk about buoyancy, if something is buoyant, it's going to float. Okay, so this is not going to work on most of ours, so we're going to skip this one because of Adobe. All right. So, let's talk about volume. So when we think about volume, I know we've been doing volume in math as well as in science, so you should be pretty familiar with it. When you think about volume, what would you say the definition of volume is? What about the characteristics? Describe volume. Yeah, I know we did a measuring volume with graduated cylinders and beakers. You can give examples. I know we found the volume when we were doing our geometry unit, and we were learning about surface area, but we also talked a little bit about volume.
What are we supposed to do on this?
So you're gonna draw right here in the Nearpod that you're gonna write about volume, your definitions, your characteristics. And give us about another 30 seconds or so. Yes, I'm going to go over this as a class. So let's talk about the definition of volume. So volume is really, it's the amount of space something takes up. And we're talking about measuring a liquid or a solid. So when we talk about solids, it's when we find that length times width times height to find out the volume or the amount of space something takes up. So this can be amount of space an object takes up. Some characteristics. So the characteristics can change based on whether it's a solid, a liquid, a gas, or plasma. However, when we're talking about a gas, the volume of gas depends on the container. However, a solid or a liquid, the volume doesn't change. So the amount of space 1 cup of water takes up will always be that 1 cup. Even if we change the container and the shape, it's always going to take up the same amount of space. However, a gas, we could take a gas, for instance, if we're talking about tires, so we can put gas inside of a tire, that air that you put inside of a tire, and it's going to be contained into that space. So the volume doesn't change, but the amount of air you put in can change. So that's where some of the characteristics of volume. Examples, we can talk about if we're measuring like a cube, so you could draw a picture of a cube. We're doing like length times width times height. And that tells us how much space that takes up. So why would you need to know that? So for instance, when I was moving, I had to figure out what size truck, what size U-Haul I needed to get. And to do that, I needed to look at the larger pieces of my furniture as well as how many boxes I had and figure out the volume of my things and if it would fit inside that truck. So by looking at the length, width, and height of my furniture and the boxes that I had, I could determine the volume of the truck I needed. And I can determine the volume of a U-Haul by measuring the length of the U-Haul, the height of the U-Haul, and the width of the U-Haul and multiplying it to make sure I got a truck large enough to move all of my things because I didn't want to do 2 trips. If you did not get to submit, that is okay. I'm going to move us on because we're running a little bit short on time. I know it's skipping. It's okay if it's skipping to a different page. So, talking about volume a little bit. Volume is the amount of space an object or substance takes up. So, I want you to click through and look at these. If you have your notebook, which you should always be taking notes. I want you to go through and write down number 1 through 6 in your notebooks. You don't have to write it word for word, but you need to make sure you write it so you understand the definition. For instance, volume is the amount of space an object or substance takes up. So just make sure you have these words and definitions written down. Maybe draw an example or sketch a picture if it helps you. The biggest thing, and you don't even have to write the actual definition if you draw a picture that really helps you understand it. But you need to know that volume is the amount of space an object or substance takes up. I'm going to give us 5 minutes to write these down. Again, if you need more time, you can always come back in here and do this. At least write down what all the words are. So if I was taking notes right now, I would write each word down and then go back and put in the definition or sketch. So that if for some reason, it disappeared. If for some reason I have to switch slides and you're not done, you at least have the word to look up. I'm putting a timer on my phone. Zoe, do you have a question?
Yes. If this is the same thing that we have to do for science, if we did the Nearpod for this right now in the lesson, do we still have to do it for the work?
Whether you've done it or not, make sure that you at least get these definitions written down. If you already wrote them down because you did this earlier, no, you don't have to do it again. But if you did the Nearpod earlier but didn't write these down in your notebook, please write these words down in your notebook now.
Okay.
We have about 4 minutes left. I'm going to give you a countdown as we go. We have about 3 minutes left. And when you get to ratios, that's what we're learning about right now in math. So you see how math and science really, they go together a lot. If you're done, we still have about 2 minutes because everyone writes at different speeds. So you can go grab a quick drink or something. We have about 2 minutes left. While you're writing, I want to talk about the law of conservation of matter. I know this is kind of a new vocabulary word. You've heard of mass and volume. You've heard of ratio, at least in math. But this law of conservation of matter, it sounds complicated, but it's really not. Essentially, I'm going to read the definition first. The law of conservation of matter is a principle of matter conservation that states that the mass of the object or collection of objects never changes over time, no matter how the constitute parts rearrange themselves. You're like, okay, what does that mean? Because that's a lot. And then you see this picture of a fire and then ashes. So what does all of this mean? What this means is that matter is anything that takes up space. Matter is air. We are made up of matter. We learned about that, when we're talking about atoms. So anything that has matter. So that includes our air, our oxygen, our gases, our solids, our liquids, our plasma. That matter, the mass of that object or collection of objects. So like as a person, we are a collection of different elements, right? We're not made up of only one element. So we're a collection of objects or elements. Our mass, of each of the objects never changes over time. I go, wait a minute, my mass is changing, I'm growing, right? You're, becoming young adults. And what that means is, how do you grow? Like, what makes you grow? And, it's from the food that you eat, and honestly, the air you breathe, and the things you're exposed to in your environment. So what that means is, when you're eating something, or you're drinking, that matter that you're eating, because food is matter, has to go somewhere. So it either becomes part of you, or it leaves your body in some other way, as you know. So what this means is nothing ever loses its mass. It just changes its form. So in our universe, in our world, we have the same amount of matter always. So matter is never created or destroyed. And that's probably the simpler way to say this, that matter can never be created or destroyed. It just changes its form. Yes, what's your question? And how do you say your name?
My name is Giuseppe,
Giuseppe.
and how about like whenever you're growing plants and stuff?
Say that one more time. Whenever you're what?
Like whenever you're growing plants.
So when you're growing plants, the reason plants grow, so they're getting larger. So you feel like, okay, well, you're creating something, but really you're transferring the energy and you're transferring the matter from, water, sunlight, and the soil and the nutrients that the plant is able to absorb. And so that matter is transferred, that energy is transferred into the plant. Raina?
I have another live session in 2 minutes.
Yes, and so I was about to end this.
Yeah, is it like done, or is it gonna go over 11 o'clock?
So we are going to stop. We've gone over what density is. So I wanted to end it on. If I can get to it. I wanted it to end on making sure you understand that the density, or how dense or tightly packed something is, does not change based on the amount. And that's because we are dividing it by the volume. So you could have a giant pool of water and a single cup of water, and they're going to be the same density. But then I also want you to understand, if we take that same water and we boil it, and that same water becomes a vapor, it is now less dense. So adding heat makes it less dense, so it's going to float. Those hot air balloons are going to float because they become less dense. They're light. Less dense is light. More dense is heavy. So heat makes things rise, like smoke rises. So less dense heat rises up. So make sure you have that kind of down in your notes. That's really like the two concepts that you should have at this point. I realize you all have a live session in about 5 minutes for 11 o'clock if you are with Miss Curran. And if you are with me, we're going to do a short math session from 11 to 11:30 if you needed help with the ratios and the double number lines. So I hope you all have a great, great day. In our assignments for my class, I don't know what Miss Curran has. We do have an exit ticket for the Nearpod. So make sure you complete that today for science, and that's all you have for science. And math, all we have in my class today is this live session. You don't even have an assignment today. Raina, you have a question?
Sorry, I just forgot to
Okay.
put down my hand.
Leah?
So, is this science?
This is science, and we're about to start math. And I'm going to give you all a 10-minute break because I know I need to get up and walk around for a minute.
Okay. So for science, do we have to do any assignments?
Yes. So I'm going to actually show it to you really quick.
Okay.
So if you're in Miss Curran's science class, you may leave. If you're in my science class, bye. Thank you all for coming. What you're going to be doing for our exit ticket. So you'll go, to this week. Here, I'm going to start in the beginning. So you'll click on this week. And under Wednesday, we just did the Nearpod, so you don't need to do that. And then you'll see this exit ticket. So for this exit ticket, there's a video for you to watch. It's very short. Just a couple minutes, and then you're going to answer these 2 questions in about 4 sentences, which means I just need lots of detail. I need to know that you understand. When you watch this, you'll see of why. So first, you're going to describe what you see in the colors. And then you're going to explain why don't the colors mix together. And it's going to be based on density, and use your knowledge of how different materials that have different densities. Okay?
Is that all for science?
That's all for science.
Okay.
Yep. Today should be a
Okay,
pretty
bye, Miss
easy day.
Nickerson.
Bye. All right, Zoe, did you have a question?
Yes. Before the lesson, when I was trying to get onto the exit ticket for Nearpot, like you just showed,
Yes.
mine says that it's locked. Bye.
Bye. All right, so if you are going to be
Bye.
in here for math, you can go take about a 10-minute break. We're going to start back at like 11:10. So I'm going to set a timer here on my phone. About 10 minutes from right now. So go get a drink, anything that you need. And I'm going to see if I can figure out why this is not working. Bye.
Bye.